Okay, so I love queso. It's delicious. People say okay, so I just I can't believe I started that way. Oh well, give you something to laugh at me for. This video is about properties of complex numbers. Not all the properties, but there's a couple of really cool ones that I want to take a look at. The first one that we're going to look at is the absolute value. So here we're going to take a look at the absolute value of complex numbers. Okay. Since complex numbers are in the form of a plus bi, how would I find the absolute value of that? Right? How do you make something? What's the distance away from 0 on a number line? What would be the distance away from there? What? That's weird, right? That's really strange. So before we get to this, let's take a look at something a little bit different here. Let's say we want to get a visual, right? Because absolute value is a distance away from 0 on a number line. Well, how do you have a number line? What is a number line for complex numbers going to look like? Well, complex numbers have two parts, right? A complex number has the real parts and it has the imaginary parts. So I could, in theory, take a look at this as real and imaginary. So I could plot things like, 4 minus 2i, the real part for 4. Let's do something erasable here. So 4 minus 2i would be 4 in the real, and the imaginary would be -2. So it would be 1, 2, 3, 4. That would be this point right here, right? But what about something like, -2 plus 5i? All right, well, -2 plus 5i, the real part's -2. The imaginary part's 5, so -2, 1, 2, 3, 4, 5. That would be this point here. So what I'm saying is the xy ordered plane can turn into something like x plus yi, right? Where x is the real and y is the imaginary. So let's go back and think about the definition for absolute value. The definition for absolute value is distance away from 0 on a number line. So what would the distance away from the origin on a number line look like? Well, let's take a random number here. Let's do, let's go, oh, that's so easy. I don't want to do something easy. Let's do something, yeah, you know what? Let's do that 4 plus 2i. 4 plus 2i, here. I want to figure out what the distance away from the origin is. So what's that distance from the origin to that point? Mason is just wiggling in his chair because I know he knows the answer to this. Because we did this in geometry. But if you turn this into a right triangle, we have a right triangle here. Right triangles we can look at as A, B, C, right? Where we have A squared plus B squared equals C squared. And if I want to get C by itself, that C value, I would square root both sides, right? I would square root both sides. So C would equal the square root of A squared plus B squared. Or, to think about it in terms of your X's and your Y's, or the reals and the imaginaries, the absolute value, so the absolute value would equal the square root of X squared plus Y squared, or your A squared plus B squared in the terms of complex numbers, right? So the absolute value of complex numbers, it is the distance from the origin on the real imaginary plane. And we're going to give it a formula. The absolute value of A plus BI is equal to the square root of A squared plus B squared. And that's our formula that we're going to use. This is why it works, but this is our formula. Okay? So let's try it out. Let's try it out. Let's see what we can do here. First example. All right, find the absolute value of the following complex numbers. Ooh. So 3 minus 6i. 3 minus 6i. So that's going to be the square root of 3 squared plus negative 6 squared. Wow. Come on, Stevens, get it together. All right, well, 3 squared, we know. 3 squared is 9. And 6 squared is 36. 9 plus 36, so 7, 3, 8, 3, 9. Ooh, I got it. Now we have the square root of 45. Now I want to simplify the square root of 45. So what is a perfect square that goes into 45 nicely? 9. Good job. So I can break that into the square root of 9 times 5, which is equal to the square root of 9 times the square root of 5. And that gives me 3 root 5. All right, I want exact answers only. Exact answers only. If you were to plug this into the calculator, right, you'd get, see, the square root of 45, 6.708, right? 6.708, something like that's going to go on forever. It'll go on forever. So if I were to round it, that would be an approximate answer. 6.708 would just be approximate. I'm looking for exact answers. So I want you to simplify the radical into this most simple form. And this 3 root 5 would be the most exact form. All right, let's take a look at the next guy here. The absolute value of 8 minus 3i. So plug it in our formula. 8 squared plus negative 3 squared. So we get the square root. 8 squared is 64. 3 squared is 9. Or negative 3 squared is 9, excuse me. 64 plus 9, so we got the square root of 73. And the square root of 73, I could try a bunch of different ones. All right, so 2, 4, 9 is not in there. 16 is not in there. 25, 36, 49, no. So this, I can't simplify any further. So the square root of 73, and if you needed to, you could do 73 divided by 4 to see. No. 73 divided by 9. No. 73 divided by 16, obviously not. 73 divided by 25 is not there. 73 divided by 49, which is more than halfway. No. That's not it. Right? 73 divided by 64 is obviously not going to be a whole number, right? So one quick way of doing it is just divide it by all the perfect squares to see. See if it can reduce in any way. So that's how you find absolute values, right? It's a pretty simple formula. Just plug your numbers in your formula. Remember, the square of a negative number is always going to be positive. So -6 times a -6 is a +36. Right? -3 times -3 is +9. Right? And that is that would be considered like the distance away from the origin. Right? The distance away from the origin on the complex imaginary plane, or the real imaginary plane. So that distance, right? That distance away from the origin. Right? So let's take a look at some more practice problems that you might see on this homework set. Identify each complex number graphed. Oh, okay. So what would the complex number be that is graphed here? Well, the real part is 1, 2, 3, 4. The imaginary part is 2. So this number would be 4 plus 2i. What about this one here? On the real number line, we got 1, 2, 3, 4. So -5. For the imaginary, it's 1, 2, 3, 4. So -5 minus 4i would be this imaginary number here, or complex number, right? Here, the imaginary axis and the complex number. This one, we have -1 real and 3 for imaginary. So -1 plus 3i would be that complex number. What about this one? We're right on the axis. So 0 for the real and -3. So it'd just be -3i for that last one.